Hi all. Today we are going to discussing allow to digital converting program. So here I have written the allow to digital converting program in Keel embedded C program for LPC 1769. Okay. So here initially let header file, the ADC initialization, and another read program. This program already I have explained, but another extra feature it is there, that is I'm explaining what is that extra feature is just now. So here main program, this is the initialization of the program, and this is the reading the character. So whenever analog input, which is at there are six channels are there in ADC. You can see here the peripheral. So after debugging, we can observe this peripheral analog A to D converter. So this is the A to D converter. Here AIN 0, AIN 1, 2, 3, 4, 5, 6, 7 channels are there. Here the analog input we have to give the input. We have to give the input for analog. So that input we can give by using the external oscillos CRO like that. But in the simulation itself, we can give the input. That is the important point today in this video lecture. So how can we give the simulation analog input to the analog to digital converter? So for that, we have to go to the help. Here in this help, microvision help. There, simulation is there. Click on the simulation. There, sine wave generation is there. Sine wave. So this is the predefined code written for generation of the sine wave. So now copy this code. So don't use the keyboard for copying, that is Control C. So right click and copy. Sometimes that keyboard Control C is not working. Okay. So this is the code for generation of the sine wave input for analog to digital converter. Now that input, this one we should paste here, that is go to the debug and function editor. In this function editor, create one value, that is one another name SAT something 2 like that. So open. Here it is showing that SAT2 is not there. Already it is not existed. It will create the new one. Okay. Now whatever the code we have copied, paste here. So this is the program for generation of the sine wave. Okay. Here the signal AIN2. Actually, you can use any channel. So for example, we are using this input channel. If you want to use this input channel, you can write this as a 0. So similarly, these are the variables: voltage, frequency. For generation of the sine wave, voltage is required, frequency is required, offset, duration. So these are the values. And printf sine wave square on. And here this is the time period for this. So it should use the system clock. So C clock. You have to change this C clock. CLK clock as the input source. Duration time period. So you get 2 omega. Okay, now this is 2 omega. 2 omega, omega means 2 pi. 2 into pi value 3.144. So this is the main instruction for generation of the sine wave. So this is the, we are AIN 2. We are not going to give the input at the second channel. We are going to give the input at the zeroth channel. And again, so here there is a button will generate in the window button. But for generation, but whenever you are pressing the button, the sine wave will generate. For that, we have to use this command button. Okay, I will show that button also. So now save this one and then compile. It will be compiled in the command window. It will compile in the command window. You can see this is the command window. Here the define button. So button is defined. So after that, we have to include this in the keel programming. For that, we have to use the command include inclu include space name of the file. What is the name of the file? This one SATG2 SAT2 dot ini. Now press enter. Now press enter. So function AIN 0 underscore sign already exists. Redefine. No need to define. Okay. No. So now, so this is completed. The portion is completed. Now we can run this program. We can run this. We can see the analog input here. So to see the sine wave, to see the sine wave, logic analyzer will display the sine wave. How to display that one? We have to do the setup here. So here we have to mention the AIN 0. So the corresponding wave which is there in the AIN 0 will be displayed here. If it is not there, you have to add. For example, this is add AIN 0. Enter. Okay, so this should be analog. Sine wave is analog. Okay, close. Now run this program. Run this program. So there is no wave is displaying. So when it will be displayed, there is a button. When you press the button, the wave will be displayed. That button will be displayed here. You can see AIN 0 sign. Now press this one. You can see sine wave is generating here. Sine wave is generating here. You can see this is the sine wave. So we have given the very less time period, that's why it will be 100 here. If you are seeing the value in the side here a and 0, those values already stopped means that way that value fixed. If it is running continuously, the analog voltage will be displayed here. The corresponding analog voltage will be converted to digital here. Digital here. So again, if you want to see, again press this one. Okay, you can see these the values are changes and corresponding display values are changes into digital. Okay, this is the so in this is the procedure to generate the input in a simulation sine wave. Okay, thank you.